So hopefully by now in 3.4 you're getting used to using your transformations and your stretches and compressions, and so now we're just going to complicate things again. And in this case they give you the original graph and they give you the messed with graph, the image, and they want you to come up with the entire formula just using the points. So it's kind of a long involved process, but it's very, very straightforward step by step. So I can't tell what my translations were until I know what my stretches and compressions were. So what I can do is I can see how the shape was changed first, and then I'll decide whether it was moved and how it was moved. So what I want to do is figure out what the scale is, basically. If I look at A and B here on the original graph, there's only one space between A and B. So I know that this line has A and this line has A prime. They're basically giving you those points and saying that's the same point, it's just now it's moved. And if I put B into the original function, then the next, if I use that value in the second function, it would end up here. So these points correspond. If the distance between A and B on the original function is only 1, then I should be able to tell the horizontal stretch or compression by looking at how that distance changed. Here, it's at -1 and 1. So this is 2. I can conclude then that the stretch is 2 for the horizontal compression. I'll show you how to do that by writing out the steps. So what I want to look at to begin with is, I'll just list my points. My point A is 1 and 1. My point B is 2 and 0.5. A prime is -1 and 4. B prime is 1 and 3. So when I'm looking for my horizontal stretch or compression, I'm going to go x of A minus x of B to find out what that number is going to be, like how different they are. And in this case, it's 1 minus 2. It doesn't really matter what the absolute value is, or sorry, it is only the absolute value that matters, so it's just, there's one space between them. Now, if I look at x of A prime minus x of B prime, then here's my x value for A prime. -1 minus 1 gives me an absolute value of 2. So what I can do here then is go, okay, well, how did I get from 1 to 2? It has to have been horizontally stretched by a factor of 2, which means that, and here's that weird flippy thing, so it's a stretch of 2, so B equals a half, right? Because remember that it's an inverse relationship. So we've got that B is a half. So I'm going to take B as a half and put it into my equation. B is a half, right? Good. Now how about the vertical stretch? We're going to do the same thing with the vertical stretch. And we're going to go y of A minus y of B. So I want to see the difference between those two values. And it's 1 and 0.5. So 1 minus 0.5 is just 0.5. Y, oh, sorry, gotta change the color. The y value for a prime minus the y value for b prime will show me the distance between those two, squishy squishy, and it's just 4 minus 3, which equals 1. So I need to have a stretch here of, how do you get from a half to 1? Well, you multiply it by 2. So I have a stretch of 2. So a equals 2. So I'm going to take a out, and I'm going to write in a 2. So now I've got